Right, so we're going to take a look at section 1.5. 1.5 is on quadratic functions, okay, how we graph them, and basically what we can do to a quadratic function to move it. Okay, we'll talk about how we can transform it. So in general, that's how a quadratic function is written. Okay, or at least that's one way to write it. Ax squared plus bx plus c. And a, b, and c can be any real number that you want, except a cannot be 0. What would happen if you filled in 0 for a? Yeah, it would just become this. If you fill in 0 for a, now you have bx plus c. What would that be if you graph it? Yeah, that'd be linear. That'd just be a line. Okay, so we don't want to wipe out that first term. So a, b, and c, anything you want, except a cannot be 0. Okay, the simplest quadratic function you can have is y equals x squared. Does anybody remember what that shape looks like?
U.
Yeah, it's like a U shape. Okay, with its minimum right at the origin. Sometimes this is called the parent quadratic function because all other quadratics come from this one. That's the most basic one you can have. Okay, what I can do is just, there's your graph. Right, so that's the graph of y equals x squared. Okay, let's see what happens when we put a negative in for x. Okay, and there's two ways I can do it. I could put the negative inside parentheses and then square it, or I could put it in front. And it does make a difference. Okay, I'm going to do it this way first. Okay, what happens when you square something that has a negative? It becomes positive. Okay, so basically, what's going to happen here? Compare your two graphs. They're identical. Right? They look the same. And the reason they look the same here is because this graph is centered right on the y-axis. Let me show you a graph that's not centered on the y-axis and plug that negative in. All right, so let's take and do a +2. Okay. What that's going to do is it's going to shift it. It actually shifts it left a couple units. We'll talk more about that in a minute. But let me show you what happens if you do the same thing, oops, but put in a negative for x. Okay. This time you will see a difference because the graph is not going to be centered right on the y-axis. Okay. What happens here is it's basically a mirror image. Okay. If you take the graph in blue and you flip it over the y-axis, you would get the graph in red. Okay. You can kind of see it right here too. If you flip this piece over the y-axis, you get that piece. If you flip this piece over the y-axis, you get that piece. Does everyone see that symmetry? See what I'm talking about? So that's what a negative does inside the parentheses. It will flip the graph over the y-axis. Right, so I already mentioned this. For the parent function, the most basic one you can have, the y-axis is a line of symmetry. That's why we didn't see anything when you flipped this one, because it's symmetrical on that y-axis. Okay, this graph contains a low point. We call that a vertex. If you take the parabola and flip it so it's more of like an N shape, then what happens is that vertex goes from being a low point to a highest point. Okay, but it's still called a vertex. Okay, so your vertex is either the lowest point or the highest point. All right, so what I'm going to do is just play around with graphing these things. Okay, we know what y equals x squared looks like. Let's see what happens when we throw a number in front of it. Okay, that's going to do something to the graph. Okay, it's going to transform it in some way. Okay, so let me put in y equals x squared. And let's try y equals 1/3 x. Okay, to type in the fraction, you can just do it in parentheses. Just like that, 1/3 x squared. All right, there's the original. And that's what happens when you put a 1/3 in front of it. What happened there? There's two ways you could describe it. You could think about it vertically, or you could think about it horizontally. It got what?
It got like?
Yeah, if you think about it horizontally, it's kind of stretched out. Or if you think about it vertically, kind of think of taking that blue one and squishing it down, right? If you squish it down, it gets spread out more, right? So we could say that it compressed vertically. Okay, let's try one more. Let's throw 2x squared in there. Okay, notice that one, you could think about it as it compressed horizontally, or it stretched out vertically. Imagine this point at the origin is fixed, and you took the two ends of the blue one and pulled up on it, right? It would start to get skinnier. Okay, it stretched out vertically. Right, so that's what that number in front does. Okay, and the key is that number bigger than 1 or less than 1? If you put a number in front of x that's bigger than 1, okay, it's going to cause your graph to stretch vertically. If you put a number in that's between 0 and 1, that's going to cause it to shrink vertically or compress. Okay, like 1/3, 0.5, things like that. So any questions on what putting a number in front of x squared does? It's either going to stretch it or compress it vertically. Okay, it's basically the same graphs I just had before. The only difference is now I'm putting in a negative with it. Now the negative, it's not in parentheses. Okay, I kind of talked to you about what that does a little bit already. What do you think putting a negative in front is going to do? It's going to cause something similar that happened before, but a little different. Yeah? So what would happen to the picture? What do you think? The number is going to control whether it stretches or shrinks. But the negative is going to do something else to it. But yes, there will be some stretching and shrinking here. And the negative, Adriana? Yeah, it's going to flip it over the x-axis. Okay, so it's going to take all these parabolas and make them, instead of U-shapes, look like N-shapes. Okay, I'll just do one of them. So you can see it. There's your parabola now. All right, so putting a negative in front, not in parentheses, this would totally change what it does. Okay, but putting that negative not in parentheses causes it to flip over the x-axis. Or you can say reflect. Some people call that a reflection. All right, so kind of problems you're going to see here is I'll give you the real basic function, y equals x squared. I'll give you one that's transformed. And I'll basically say, how would you transform this into that? Okay, in this case, there's two things happening. The 5 is going to do something, and the negative is going to do something else. Okay, let's start with the 5. Okay, what is that 5 going to do? Actually, we haven't talked about shifting up and down yet. That's going to be the next thing we do, up and down and left and right. Anybody else remind me, when you put a number in front bigger than 1, what does that cause to happen, Gene? Yeah, and what do we call that? We just have to name the transformation.
The stretch vertically?
Yes. So the way you describe it, say it's a vertical stretch. Okay, that's only half of it though, but you got to say how much. It's a vertical stretch by a factor of 5. All right, so you described it. It's a vertical stretch, and then you said how much. Factor of 5. Okay, and the last thing, after you stretch it by a factor of 5, Eric, what's that negative going to cause to happen? Yep, and what's the transformation? So when you take something and you... Yeah, you could say it's going to flip over which axis? X-axis. So flip or reflect. Right, so again, notice two things. What kind of transformation? Where it's occurring. It's reflecting over the x-axis. And that's it. That's all that's happening there. Okay, there is a certain order you want to make sure you do it in. For now, I'm guiding you through the order, but at the end of class, I'll show you the order to do it in. All right. All right, let's try this one. Any guesses what, let's start with x squared plus 2. What do you think putting a plus 2 on the end is going to do? Yeah. All right, so one option is it moves left to right. The other option would be up or down. Okay, let's see which one it is. So let's take x squared plus 2. In this case, it did shift it up. Okay, it shifted it up 2 units. So they're asking me, how would you get y equals x squared plus 2 from y equals x squared? So I would write to get x squared plus 2, y equals x squared, shift y equals x squared up 2. Okay, and likewise, I could graph this other one, but I think you can probably figure out what it's going to do. What do you think x squared minus 3 does? It's going to go down 3. It's going to go down 3. All right, so to get y equals x squared minus 3, y equals x squared, shift y equals x squared down 2. Sorry, down 3. Down 3. Right, so these are examples of what we call rigid motion transformations. They do not stretch the graph in any way. They just take exactly what you have and move it to a new spot. But they don't stretch it out. All right, so vertical shifts have the form x squared plus k. Again, if k is a negative, it would become x squared minus k. And this one's pretty straightforward. If you have a number greater than 0 for k, you shift up, okay? Like plus 2, plus 3. If you've got a number less than 0, you shift down absolute value of k units. Why do you think I put absolute values around k?
So, k for
Okay, but what would be kind of awkward if you didn't put absolute values around k? and you describe shifting down, how would it sound? Yeah, it would sound weird. You'd say shift down -4 units. Okay, don't say something like that. Okay, down takes care of the negative. Shift down 4 units, not down -4. Okay. Just like you wouldn't say shift up -2 units. You just say shift up 3 units, or whatever it is. So any question on shifting a parabola up or down? And we got another one. Okay, what do you think? We're doing a minus and a plus, but now it's going to be inside parentheses. What do you think that'll do?
Left, right.
Yeah, this is going to be left or right. Which way do you think minus is going to go?
Left.
You think minus is going to go which way?
Right. Left. Left.
It's going to go west.
You're saying left and right, but you're confused. You're pointing the opposite way of what you're saying. I'm confused.
Left.
So, go ahead. Left? You think it's going to go that way? All right. And then right towards the door? Okay. So let's try -3 and let's see if it goes left. You would think it goes left because on the number line, negatives go towards the left. All right, so let's take x -3 squared. And it actually shifted it to the right. Okay. So this one is a little tricky to remember. All right, so how could we, let's see, get that? So to get y equals x -3 squared, okay, shift y equals x squared, right 3 units. And to get, what's the other one? X plus 2 squared. Shift y equals x squared. How do you think you would shift to get x plus 2?
Left.
Left, how many?
2.
Yeah, you'd shift left 2. Okay, so these are examples of horizontal shifts. Okay, again, that's a rigid motion transformation. There's no stretching at all happening here. No stretching or compressing. Just taking what you have and moving it somewhere else. Okay, and this is how I try to remember which way is left and which way is right. Okay, what I do is always rewrite it so that it's x minus something. All right? So for example, if I had x plus 2 squared, what I would do is think of it this way. Instead of x plus 2, think of it like that. Okay. Minus a minus would become a plus. Okay. And then what I do is just focus on the number that's after the minus sign. If the number after the minus sign, okay, block the minus sign out. If the number after the minus sign is greater than 0, shift right. If the number after the minus sign is less than 0, like in this case, it's a -2, shift left. So that's how I think about it. Anytime I get something that has a plus in here, I rewrite it as minus a minus. Block out the minus sign. Look at what comes after it. If it's positive after the minus sign, shift right. If it's negative, like in this one, shift left. Okay, and as we shift the parabola left and right, up and down, we're also shifting the vertex. Well, there's only two things you have to look at when you shift your vertex. Did you shift it up or down? And did you shift it left or right?
So is K always going to be up and down, and H always going to be left and right?
Yes. Yes. All right. So if you want to know where does your vertex go after you do this shifting, well, look at how much you shifted left or right. That's the x value of your vertex. And look at how much you shifted up and down. That's the y value of your vertex. Right? So if you had a vertex that always, bless you, always starts at the origin, and if you shifted right 1 and up 1, well, now the vertex would be at 1, 1. Right? In that case, you'd have a 1 for h and a 1 for k. And that would make your vertex again 1, 1. Okay, and the line of symmetry, well, that moves with the parabola as you shift it. But the only thing that the line of symmetry is affected by, bless you, is moving left and right. The reason up and down doesn't affect it is because think of your parabola like this. If you shift it up, it still has the same line of symmetry. It's only if you shift it over here, to the left or to the right, now it has a new line of symmetry. Remember vertical? Bless you. Vertical always starts out x equals a number. And in this case, it's just x equals h. That's where your line of symmetry would be. All right, we're going to try an example of that. Okay, first thing I want to do is find my vertex. Right, before I even start, one thing I would do is look at this x plus 2, and I would rewrite it. Okay? How could I rewrite x plus 2 with a minus?
Minus.
Yeah, let's write it as x minus minus 2. Right? Let's start with shifting left and right. Okay. In this case, did I shift left or did I shift right?
Right.
Look at the number after the minus sign.
Left.
It's less than 0, so we shifted left 2 units. Right? That's why it's negative. Right? And then what about the minus 3?
One.
Yep, so look at what comes after the minus sign. If it's less than 0, you shift left. And what about the minus 3? Which direction is that? Down. So we went left 2, down 3. What would be the coordinates if you started at the origin and went left 2, down 3? Negative 2, negative 3. H, K. There's your vertex. Okay. Line of symmetry always starts out with which letter?
And then X1.
X equals.
H. Then
X equals negative 3.
2.
Well, remember, shifting, this is up and down, right?
Yeah.
The negative 3. All we care about with line of symmetry is left and right.
Oh, that was a right. And
Negative 2. Okay, if I had a parabola here and I shifted it down 3, they still have the same line of symmetry. It's only shifting it left and right. Okay, any questions on finding your vertex or line of symmetry? Yeah.
So with the H, is it fair to say that basically H will always be the opposite of whatever it is?
You could think of it that way if you
And
don't
K
want to
will
rewrite
always be
it.
the same as it is?
Yeah.
Okay, because that's what Genesis Trinity would just say it like that. It
Got
just
it.
stuck with me.
Some people don't rewrite it and they just say, okay, I'll just look at that all the time and take the opposite. I rewrite it so I can see the opposite. But same idea. Yep. All right, so another one where we're going to describe how we can get from the basic function to the new one. Okay, and the order that we write them in does matter. Okay, first, how many transformations are happening from x squared to 5x squared plus 4? 2. Okay, there's 2. Okay, and for this one, the way you can think about it is just think of PEMDAS. Right? If you were to plug something in and square it, what's the first thing you would do? Multiply by 5? Or would you add 4? You'd multiply by 5. Okay. All right, so Brendan, can you tell me what happens when I put 5 in front of x squared? What does that 5 cause it to do?
Shift up.
Not yet. That's going to be the plus 4. That 5 goes back. It's the very first one we did. Remember that very first one, if you put a number in front of it greater than 1? This one's not a rigid motion transformation. Okay, you're on the right track. Anybody help him out? Yeah, John?
It's a stretch vertically by a factor of 5.
Yeah. So this is a vertical stretch by a factor of 5. Okay. Even if it was a number less than 1, I would still say vertical stretch by a factor of, and you could say whatever the number is, 1/3. Okay, don't get into using the word vertical shrink, because then it's kind of like saying moving down -2 units. You're kind of mixing things up a little bit. So always say vertical stretch by a factor of, and write whatever number is right there. Okay? I'll understand if you write a number less than 1, it's a shrink. You don't have to write that though. Okay, just put the fraction right there. All right, and the second step. Matt, what's that plus 4 going to do?
Move it down 4, up 4.
Yeah, that's a shift up 4 units. Shift up 4 units. So we'll try this one, and then I'll show you the order that you always have to do it in. But this is actually going to be a good example to show you the order. Okay, how many transformations are happening here? Nope, not 3. 4. Okay, 4 things are happening here. Okay, and again, thinking of PEMDAS, okay, we would start inside the parentheses. Okay, so first thing we're going to do is deal with that -1. Shannon, what's that -1 inside parentheses going to do? Yep, how many units? Perfect. So look at what comes after that minus sign, or take the opposite if you think that way. What comes after the minus sign is a +1. So it's going to shift right 1 unit. All right, next thing we're going to look at is this 3. And that'd be the next thing we would deal with. Nick, what's that 3 going to do? Well, we've already done the left and the right. Okay, so left and right is done. Now, up and down will be the very last thing. So this is when you multiply by a number in front. Yeah?
Stretch.
Yep, by how much?
Motion. By -3.
Yep, forget about that negative. That's going to be its own separate thing.
Stretch by 3.
Yes, so that's a vertical stretch by a factor of 3. Right? Because because you're multiplying what's being squared by a number. So that's number in front.
Just ignore the negative.
Nope, now that's step 3. So now what's that negative going to do?
Make it down.
Yeah, I heard flip. Which way?
And flip over the x-axis.
Over the x-axis, yes. Flip over x-axis. And now the last thing would be the +4. How about, let's see, Kyle, what's that? Yeah, go ahead.
I was gonna say, shifts to the right for you. Wait, no, shifts up for you.
Up 4 units. All right, so it's shift up 4. And that's the order that you pretty much always want to do it in. Okay, always deal with your horizontal shifting. Okay, first, that's inside the parentheses. Then deal with any vertical stretching. That's the number on the outside. Okay, if you have a reflection, we can deal with that as well. If there's no negative, you wouldn't have a reflection. And then the very last thing is your vertical shift. All right, so if I just go ahead and label it. Okay, this is your, how can I write this? This is the horizontal shift. In general, it could be left or it could be right. This is the vertical shift. Okay, it could be up or it could be down. This is your vertical stretch. Right there. And that's your reflection over the x-axis, or flip. Right, you just got to get used to what each part does. But that's the most complicated one you could really have. Okay, any questions before we look at our last type of problem? Yeah. Okay, any other questions before we look at our last type? All right. So all the examples that we've been doing up until now have been in what we call standard form. Okay. They've got the number in front, which tells you the stretch. They got the plus or minus h, which tells you your left and right. And they've got the plus or minus k on the end, which tells you your up and down. Okay. Very easy to figure out the transformation if it's written that way. Well, sometimes it might not be written that way. They might take and rewrite it something like that. 3x squared plus 12x minus 18. This is the same type of equation. Okay, the only difference is it's basically like somebody decided to FOIL out the x minus h squared and then distribute the a and write it like you were going to write it if you were going to factor it. Well, that's great if you want to factor it, but it's not so great if you want to describe the transformations. Right, so what we have to do is just take it, rewrite it, and the technique you use for doing that is completing the square. Okay, in Algebra 1, I normally go through a good day, maybe 2 days, on how to complete the square. What I'll do here is I'll just show you with an example. Hopefully that'll kind of refresh your memory a little bit on how to do it. Does anybody remember doing that last year from Algebra 2? Okay, yeah, so that's actually a little more recent than my juniors that take pre-cal had geometry the year before, so they haven't done this in a couple years. Okay, but maybe some people remember it. All right, so same kind of question. I want you to describe how you can transform y equals x squared into that. But it's not written in the form that we need. Okay, that's what we got to get. All right, so let me show you how you complete the square. Okay, as we're completing the square, the most important thing to remember is we got to keep the equation balanced. If we do anything on the left, we got to do it on the right. All right, so first thing I'm going to do is copy down my equation. And you set it equal to 0. Okay, so if I had something like this, my first step would be move the 18 to the other side and get it equal to 0. Okay, in this problem, I've already done that for you. All right, so we start with that. Any questions so far? All right, so now, the reason I like to get everything on one side to start is I want to make sure my x squared term is positive. Okay, I just like it with that positive. Okay, middle term here could be positive or negative. Okay, and now I have the 18. All right, so my next step, I think this will make it a little easier. Let's put that 18 back on the other side. All right, so this step, put constant on other side. Some people just like to write it like that right away. Okay? I just tend to put it equal to 0 first, and then I start moving things around. Mainly so I can make sure x squared is positive. If you want to do that in your head right away, that's fine. All right, next step. Whenever you want to complete the square, the coefficient of x squared has to be a 1. Can't be a 3.
Divide by 3.
Yeah, what we're going to do is basically factor it out. Okay, so put a 3 on the outside. And what would be left?
X squared plus 4.
Yeah, x squared plus 4x. All right, so now we get the constant on the other side, and we get the coefficient of x squared.
We just don't
1.
integrate.
So make coefficient of x squared equal to 1.
Can we divide 18 by 3 too?
No, don't do that.
Don't do it.
Nope.
Okay.
No. I can show you why if we have time after, but yeah, just do it like that. All right, next step. Here's where we're going to complete the square. Okay, so leave a little bit of room, because you're going to add something in. Okay, and what you add in here, there's 2 steps to find it. And it has to do with this number right here. Does anybody remember the 2 things you do with that number to find what you add to both sides? Sure?
Half it and then you square it, right? Like divide by
Yeah, perfect. You take half of it and then you square it. So what is that, Cheryl? Half of 4 is 2, and then squared? 4. So not very interesting here. And now what do we have to add on the left?
4. Or negative 4.
Okay, be careful with what I really just added on the right. This plus 4 is correct, but I did not add 4 on the right. Anybody see what I really added? Look at that carefully. If you were to do out that right-hand side, that would not be a plus 4 when you do it out. What would it be? It would be a plus 12. Can you explain why?
Distribute.
Right. Anything that you put inside these parentheses is really tripled. All right? So when you put a plus 4 here, you really just added 12 on the right. So what does that mean I have to add on the left? 12. That's the biggest mistake people always make. They forget that they had something on the outside. Now, there might be problems where this number was already a 1 to begin with in front of x squared. You don't factor anything out. That's easier. Okay? Then you don't have to think about what I just said. But I'm trying to show you one where you do. All right. Next step, just add 12 and 18. And now this is going to factor very nicely. if we added the right number, it should factor into something times something, and they should both be the same.
Plus 2, f minus
Whoopie, what do you think it is?
2, f plus 2,
X plus 2 and,
f minus 2,
nope, they got to be the same.
plus 2.
X plus 2. Okay, X plus 2, X plus 2. If you didn't add the right number to both sides, this won't happen. Okay, but we did. So now I'm going to write it as this. Okay, now we're starting to get it in that format we want. And my last step is to bring the 30 back to the other side. Does anybody see why I didn't want to divide everything by 3? What is this 3 telling me? What kind of transformation?
The vertical stretch.
Yep. If I had divided everything by 3, I would have lost that. Okay, I would have lost that vertical stretch by a factor of 3. Okay, so now just write down the 3 transformations that are happening. Okay, the 2 is going to do something, then the 3, which we just mentioned, and then the negative 30. All right, Pat, can you tell me what that plus 2 is going to do?
It's gonna
Or think of it that way if that helps.
move it to the right 2,
Okay, look at the number that comes after the minus sign. What is the number?
the negative
Negative,
2,
and negative goes
to the left.
left. So left 2. It takes a little practice just to get used to that. Okay, as I think it was Cameron said about thinking of the opposite. Just got to get used to that. Only when it's inside parentheses, not outside. Okay, the 3. Somebody just said that. Yep.
Vertically stretched by 3.
Yep, vertical stretch by a factor of 3. Okay, and the last one. What's the minus 30 going to do? Well, Jill?
Down 30?
Yeah, it's going to shift down 30. Okay, so she said both things that were important. She told me the direction, and she told me how much. Okay, each one has 2 parts to it. How much? What type of transformation? How much? What type? Okay. So, any questions on that? Right, so that's basically how you can transform quadratics. That covers all the transformations. Question?
So I think I have it break down wrong. So if the x has a negative number next to it, it's a reflection over the x-axis, not the y-axis.
Yeah, if you do this, okay, versus this, okay, this is going to be a reflection over the x-axis.
Oh, okay. I have it written down.
Okay. If I did this, that's going to reflect over the y. Okay, that's the difference. I'm going to put this up, but we're not going to talk about it too much right now. This gets into the quadratic formula a little bit. But in the quadratic formula, you'll see this b squared minus 4ac. People remember that?
Yeah.
Under the square root? Well, if basically all you want to know is how many times a graph crosses the x-axis, like a parabola, okay, there's 3 cases that can happen. You could have a parabola like this, crosses twice. Parabola like that, touches it once. Or a parabola like that, doesn't cross at all. If you want to know which of these 3 cases you have, right, and you got an equation like 2x squared plus 4x minus 5, that's A, that's B, that's C. A, B, C. Sign to the left always goes with the number. if you fill them into this formula, b squared minus 4ac, it'll tell you how many times it crosses the x-axis. It won't tell you where. But if it comes out less than 0, it'll never cross. If it equals 0, it'll just hit it one time. And if b squared minus 4ac comes out more than 0, it'll cross twice. All right, so that formula b squared minus 4ac is a little shortcut to find how many times it crosses the x-axis. All right, but we'll talk more about that when we do the quadratic formula. All right, so homework tonight, just on one page, okay, page 56. And it kind of skips around a little bit. It says 1, 2, 7, 10, 11, 16, 18, 21, 22, 28, 33, 40, 41, 44, and 60. So take a look at that tomorrow. And don't forget, this week we're going to do take-home test on Wednesday, and that'll be due Thursday.